Okay, so today we're going to be going through the 2024 Paper 1 for Edexcel, and that's going to be the foundation tier. We're going to basically dive into it and see how it goes. I've attached any of the question timestamps below, so if you want to go find those, you can click on those. But yeah, without further ado, we're going to dive straight into this. We're going to see how we get on. And yeah, if you've got any questions with it, feel free to leave them in the comments below. So, firstly, we've got right 18,475 correct to the nearest thousand. So, looking at our thousands digits over here, we've got our current thousands being 8. The next digit after it, the hundredths, is a 4, so we're going to have to round down, leaving us with 18,000. Cool. There we go. Write 0.3 as a percentage. Well, one whole is 100%. We've got 3/10 of that, or 0.3. Therefore, we want 30%. Write down the mathematical name for the angle marks y. In this case, we've got what's known as a reflex angle. A reflex angle is when you've got something greater than 180 degrees, but less than 360. So reflex. The other common two that you need to know are acute, which is bigger than 0 but less than 90, and then obtuse, which is bigger than 90 but less than 180. Okay, ordering these in terms of size. Remember, the best way to do this is always to consider the first digit first, the tenths, and we can start by looking at these. So the smallest tenths digit is 0.03. Then we've got these two, which are 0.1s. If you've got just blanks after your 10th digit, all of these are going to be zeros always. So is 0 or 6 bigger? Clearly 0.16 is bigger, so next is going to be 0.1, then 0.16. And we can repeat the same exercise over here, 0.2, then 0.21. Nice. On to question 5 now. What is the square root of 64? Well, a square root is the opposite of squaring, and squaring is when you take one number and you multiply it by itself. So if you got a bit stuck here, you'd just be thinking about those numbers. 1 times 1 is 1, 2 times 2 is 4, and eventually you'll end up with 8 times 8 is 64. So 8 is our answer to the square root of 64. Cool. Okay, moving forwards, we now have Ryan buys 4 cakes at £1.30 each, 2 identical tins of soup. He pays with a £10 note and gets £1.80 change. Fantastic. So let's start by working out how much he actually spent. We'll start with our £10 and we're going to have to take off £1.80. This leaves us with £8.20. So reducing the pounds by 1 and then the 80p to give us 20p. At the same time, let's consider how much 4 cakes cost. So we're going to have to work out 4 multiplied by £1.30. We can split this into 2 operations if you'd like. This is the same as doing 4 times £1 and 4 times by 30. If we were to carry on from here, you could work out that this would be £4 and that this here would be £1.20, and that would leave us with a total of £5.20. Cool. So now we're left with figuring out the difference between these two things. So the cakes plus the soup is going to be equal to £8.20. We now know that the cakes all cost £5.20, and we're left with this question mark for soup, right? A quick bit of maths leaves us with £3 exactly, and we know that this is 2 soups, and that's going to leave us with £1.50. Cool. Okay, moving on. The table shows the number of hours that Lena and Pavel worked on each of 4 days last week. And we want to draw on the grid a suitable diagram or chart to display this information. Okay, that's a good question. I would suggest that our best graph that we want to draw here is a bar chart, and to make sure that we use all the space that we can, let's consider how much space we're going to want to use. So let's just start by drawing out this line down the bottom. I'm doing my best here. You'd probably want to use a ruler in an exam, but there you go. It's all fine. And then down the bottom, we can consider how we want to lay this out. I'm thinking that our best way of doing it is actually if we give a column each to each of the days of the weeks, and we can put a gap in between them to make sure that everything's all a little bit more laid out nicely. So let's say that we've got Wednesdays could be here. We could have Thursdays next. Friday, I assume, would be after that. And Saturday. So Friday would be there, Saturday would be here. And then above each of them, we're going to have an L and a P, and an L and a P, and an L and a P, and an L and a P. And then on the y-axis, we can just assume that each box is going to represent that many hours worked. So 3, 4, 5, 6, 7, 8, 9, 10. Cool. So now we can just go through each one. So Lena on Wednesday had 6 hours. That's going to be here. Lena on Thursday had 9 hours. That's going to be up here. 8 and then 6. So 8 and then 6. And what I'm doing here is just putting in the tops of all of them, and then we can come back and draw the bars in a moment. So that was 7. Next was 6, 5, and then finally 6 to finish. Cool. And sometimes in these bar charts, because we've got 2 different people but on the same chart, in real life, these would be represented with different colors. But for us, maybe we'll use a different pattern or something. Maybe we could just shade in all of Lena's, and then we can basically just say, oh yeah, we've got shaded and non-shaded. There we go. Cool. Next on the scoreboard is question number 8. Work out the size of angle marked X. So a full 360-degree rotation. Think of it jumping all the way around. That's going to be 360. So we know that X plus 90 plus 220 is going to be equal to 360. So X plus 310 is equal to 360. Therefore, X is equal to 50. And give a reason for your answer. Yeah, okay, that's exactly the same idea. A full rotation is 360 degrees. So it must be 50 to get to 360. Nice. Okay, question number 9. Work out the output when the input is 13. Okay, we're passing 13 into our machine here. We want to know what comes out the other end. 13 times by 2 minus 10. So 13 times 2 is going to be 26. Take away the 10, 16. And so Lily here, work out the input when the output is 28. So we have some question mark multiplied by 2, taken away 10, equals 28. Think about it, we're working backwards through the machine. So if we took away 10 last, we add 10 to work out what's going on at this point. 38 is a placeholder. And then if we multiplied our number by 2, well, to get back to that original number, we're going to have to divide by 2. So 38 divided by 2, that's going to give us 19. So 19 here. And we could double check. We could run that back through the machine and see if it gives us 28. And lastly, show that there is a number for which the output is the same as the input. That's quite interesting. So we need to think about what sort of number, if we multiply it by 2 and then took away 10, would give us the same number. And actually that number itself is 10. 10 times by 2, take away 10, equals 10, right? Okay. Next up is question 10. There are 24 cows and 36 sheep on a farm. Work out the ratio of cows to sheep. So that starts off by just being 24 to 36. So for every 24 cows, we have 36 sheep, but we want to simplify this down. the way that we do that is we look for common factors in 24 and 36. So the easiest one I think to spot is 2. So we can divide both sides by 2. And remember here that if we do something to one side, we want to do it to both sides. So that leaves us with 12 and 18. Once again, maybe we'll spot both of these going to 2. So we can run through the same exercise again, 6 and 9. And then here you might spot that they go into 3, leaving us with 2 and 3. Now, you could argue that you can absolutely do this in one shot as well. You can immediately spot that 24 and 36 both go into 12 and divide them both by 12. But either way, you're left with 2 to 3. Cool. Right, minus 12 divided by minus 4, double negative. So this is the same as 12 over 4, which is 3. Next up, 2 to the power of 5. Remember that something to the power of a value is how many times you're multiplying the base or the thing itself that many times. So in our case here, this becomes 2 times 2 times 2 times 2 times 2. And we can essentially work our way through this. So 2 times 2 gives 4. 4 times 2 would give 8. 8 times 2 gives 16. 16 times 2 gives 32. And last but not least, write one pair of brackets in this calculation so that the answer is correct. So here we've got something that's being dictated by BIDMAS, and we want to get in the way of BIDMAS. We want to control it so that we get our right answer. So maybe let's start by just running through this and seeing what we get in accordance to BIDMAS. So BIDMAS dictates that we do division first, multiplication next, addition next, and then subtraction last. The brackets forces it to be done first, though. So following this, we do the division first, add 2 minus 4. That means we'd end up with 12 minus 4, which is 8. We're not looking for 8, we're looking for 2. So how can we alter this? What operation do we need to do first to make this happen? Well, it looks like if we were to add the 3 and the 2, we'd end up with 30 divided by 5, which would be 6, and 6 take away 4 would be 2. So our brackets have to go in there. Nice. Okay. So next up is question 12. The perimeter of the rectangle is a quarter of the perimeter of the triangle. So maybe let's just write this out, right? So perimeter of the triangle, the perimeter of the rectangle is a quarter of the perimeter of the triangle. So 1/4 of the perimeter of the triangle is equal to the perimeter of the rectangle. Okay. Now to find a perimeter, that's the distance around the outside. Imagine you're walking around the edge of these shapes. So for our perimeter of the triangle, we've got 30 along the bottom, 14 up the side, and then 36 back to where we started. So let's drop these in. 30 plus 14 plus 36. And remember, we want 1/4 of this thing. We know it's going to be equal to the perimeter of the rectangle, but we're actually missing the length in these. But we know it's a rectangle, which means that the left-hand side over here must also be 4. We're just left with a question mark length at the top and a question mark length down here. Suppose we call both of them x, then the perimeter of our rectangle would be 4 plus 4 plus x plus x. Okay, we'll come back to those x's in a moment. So let's just run through the maths here. We've got 1/4 of everything that was happening in here. So this is maybe a little bit hard to work out, but 14 plus 36 is 50. 50 plus 30 gives 80. And this is all going to be equal to everything on the right-hand side. 4 plus 4 is 8. X plus x is 2x. Next up, 1/4 of 80. How do we work that out? Well, 1/4 of something is the same as saying divided by 4. So 80 divided by 4 gives 20. And this is equal to 8 plus 2x. Next, just a little bit of algebra to get us across the line. So let's start by taking away this 8 from both sides. Think of your train tracks. To get rid of that 8, we've got to do it from both sides. And we're left with 12 equals 2x. And then finally, to get x by itself, we're going to divide by 2. And we're left with 6. So 6 is equal to x. A bit of a rabbit hole with that one is realizing that you might think perimeter is area and end up multiplying. Equally good to spot that you actually need this length twice. You need it along the top and along the bottom. Okay, nice. Okay, question 13. There are only £10 notes and £20 notes in a wallet. Ali takes a note at random. What's the probability that Ali takes a note of value of more than £5? Right, so in our wallet we've only got £10s and £20 notes. Can she take out anything less than £5? No, it's actually a trick question. This is 100% likely. Okay, and then on to part B. There are only 1p coins and 2p coins in a bag. The total value of the coins in the bag is 40p, okay? The total value of the 1p coins is the same as the total value of the 2p coins. Okay, this is a really important line here. So the total value is the same. So we've got 40p, and then we've got two piles of 20p's, right? The total value of the two piles is the same. But of course, this is a different amount of coins themselves. For example, over here we've got 20 times 1p, but over here we're going to have 10 times 2p. So that begs the question, how many coins have we got altogether? Well, we've got 20 coins in this pile and 10 coins over here. So we have 30 coins total. And then how do we get a probability? Well, the way that we get a probability is a fraction, is to go, how much of the thing is there that I want out of, divided by, the total amount that are there. So from here we can say what I want over the total, and that's going to end up being 20 over 30, which simplified, looking very quickly at these, you can divide both by 10, leaving us with 2/3. Nice. Okay, moving on to question 14. 273 times by 54. This is you can approach it using any of your multiplication techniques. Common ones are like short column multiplication, long column multiplication, but my personal favorite, Napier's Bones. And to do this, we construct a grid. In our case, it's going to be 3 by 2. And I am doing this freehand, a little bit under, timed pressure in an exam, but I'll do my best to explain what's going on. Now, you'll see that we have each of our 6 boxes having a diagonal line through it. You'll also notice that if you were to run diagonally through these, you get these sort of trenches running through them. And our objective is to put the tens in the units column, units of the multiplication between the two numbers that meet here in each box. So this one over here would be 2 multiplied by 5. Okay, so that's our objective. Let's just fill in all of these. So as we go through, 3 times 5, 15. 7 times 5, 35. 2 times 5, 10. 4 times 3, 12. 4 times 7, 28. And 4 times 2 is 8. Cool. And then our objective now is just to run down each of the diagonals. So our first diagonal gives just 2. Fantastic. The next one is going to give us 14. So we're actually going to have to carry the 1 here. I quite like to do this in a different color and put it in the diagonal that we're counting next. So here we're going to have 2 plus 8 is 10, plus 5 is 15, plus the 1 is 16, plus the extra one down here is 17. So 7, carry another 1. 1 plus 3 is 4, 1. Here we are, and our answer appears here. So our answer to this question is 14,742. Okay, on to question 15 next. We have a stem and leaf diagram. Tessa has recorded the times that 15 adults took to complete a run, okay, where the number on the left represents the tens and the number on the right represents the units of that time. So, for example, this 4-5 would be 45 minutes, the 4-9 would be 49 minutes. Firstly, we want to find the median. So the median, I like to remember this by remembering that median has a D in it, which means that it's the same as the middle. There it is. So the way that we're going to run through this is we're basically going to incrementally knock off the smallest and the largest value. So 45 cancels with 81. 49 cancels with 77. so on, and so forth. And we're left with one in the middle. There it is, 64. Excellent. Next up, let's find the range. So to find the range is a measure of spread. It's how spread out our data is. And range itself means let's take the biggest value and take away the smallest value and find out how distant apart the smallest and the biggest values are. So in our data, 81 minus 45. And in our case, this is going to leave us with a total of 36. You might want to be a little bit careful with this calculation here and not accidentally go a bit too high. Tessa also recorded the times that 15 children took to complete the run. For the children, the median was 75. Compare the times that the adults took with the times the children's took. Cool. So, in our case here, we're wanting a comparison. And for these comparison questions that are more statistical, the best thing you can do is state the values, right? So, the children, on average, took longer than the adults. Now, this would be okay, but would you guarantee the mark? Not necessarily. But if you put in the numbers, the children on average took, and this is the important bit, right? Up here, you're going to put 75 mins, comma, longer than the adults, and then you'd put 64 mins. Right? And then if by doing that, you're very clearly expressing what values they took. We can't compare the spreads. In some of these questions, you might have to be asked about the range or the spread of the data. You do exactly the same thing. You'd go, the adults had a smaller spread or a larger spread, depending on what the children have. But of course, we've got no data here on how they got on. Okay, moving on. Batteries are sold in packs of 4, in packs of 8, and in packs of 12. 4 batteries cost £1.80, 8 cost £3.20, and 12 costs £6. Which pack is the best value for money? Okay, a value for money question. So this is all about unit economics. We want to know how much one particular unit costs in each, and whichever one's got the cheapest unit, well, that's the best value for money, right? So let's just do each one at a time. We're starting with £1.80 is 4, right? So how do I figure out the value of 1? Well, I'm going to divide by 4, which in our case is probably just easiest to divide by 2 and then 2 again. So half of £1.80 gives 90p, that'd be the price of 2, and then halving again, 45p would be the price of 1. Cool. Set of 4 done. Next up is the £3.20. And for this one, we have 8 in total. So let's see how we get on here. Once again, we can just divide by 2, giving us £1.60, which would be the same as 4. Oh, and notice, right? It's immediately cheaper than this one. You already know it is. It's £1.60 for 4. And this is actually a little bit easier to divide by 4 straight away, which will give you 40p. And last but not least, the £6 over here for 12. Here, let's actually start by dividing by 3 to get us to £4. And actually, what we could have done is done this straight away. So dividing by 3 gives £2, right? Which would be the price of 4 batteries, right? Now, interestingly, upon reflection, we can compare directly the values of the 4. You don't actually need to go all the way down to 1 in this question. We can just compare packs of 4, because you know that the one that's cheapest for 4 will be the cheapest it is for 1, right? Cool. And so in our case, it was this pack here, the pack of 8. And it's cheapest at 40p per battery, or £1.60 for 4. Question 17. Here we've got our first little bit of algebra coming along. This is a expanding brackets question. So let's see what we can do. So brackets here, we want to expand these. So the number on the outside is multiplying everything on the inside. 2 times 4 gives 8x, and 2 times minus 5 will give minus 10. The 18 remains the same. Now our objective with these questions to solve for the value of x is to get x by itself, right? Currently, we've got numbers on that left-hand side. We don't want numbers on that left-hand side. We want all the numbers on the right-hand side, all the x's on the left-hand side. Okay, so let's add 10. Adding 10 is going to get rid of the 10 on this side, but we must ensure that we do it to the other side as well. 8x is equal to 28. Next up, we want to get rid of this 8 in front of the x, because our answer, we just want the value of 1x. So we're going to divide by 8, and on this side, do exactly the same thing. Divide by 8. Cool. This is going to leave us with x is equal to 28 divided by 8. There's no reason to put this as a decimal in this question. We never get asked for it to be a decimal. We might as well just leave it as a fraction like this. You could simplify it, of course. This can become, let's have a look, 14 over 4. And you can go one step further and say 7 over 2. But there's nothing specifying that we need to simplify it, so you don't have to. Next up, write down the value of 10 to the 0. Now, that's quite an interesting question. So remember that x squared is equal to x times by x, and well, x itself is just equal to x. Now, that means that to move up powers, we multiply by another one of those values. In this case, x, but if you were doing 2 squared, well, that's 2 times 2, right? Rather than just 2 itself, you'd do 2 times by another 2. What many people don't realize, though, is that to go the other way, you just divide by an x, or whatever value you're looking at. So if we wanted x to the power of 0, well, we have to divide our x by another x. And in this case, it means that we'd be left with x divided by x. But this is essentially stating that we've got some value divided by exactly the same value. If you were to try this out with a few numbers, I don't know, 4 divided by 4 or 10 divided by 10, well, you'll notice that it's always equal to 1. So the value of 10 to the power of 0 is 1. On to question 19 now. Fully describe the single transformation that maps A onto B. Okay, there's 4 transformations. You're going to want to know these. So I'm going to quickly run through them. You've got rotation. You've got a mirror. You've got a enlargement. And last but not least, you've got what's known as a translation. Now, in our case, we're looking at a translation. A translation is where you move something around a plane, and we describe this movement using a vector. Okay, it's a column of numbers where the top number is going to represent how much we're moving to the right or to the left, and the bottom number how much we're moving up or down. Now, in our case, we want to know how we move from triangle A to triangle B. And to do this, I'd suggest that we pick a point in one triangle, and we're going to get from this point to the corresponding point on the other triangle. And we've got to do this by moving just left, right, up and down. So by running through this sort of arrow technique that I like, we've gone 5 arrows to the right and 4 arrows down. And that means that our final vector will be, well, it will be a translation with our vector being 5, then minus 4. We want this minus to tell us that we're going down as opposed to up. Okay, on to question 20. Here are the first 4 terms in an arithmetic sequence. So what does it mean for something to be an arithmetic sequence? Well, it means that you're always adding by the same number. In our case, we're adding by 4. Now, it's our job to find an nth term. An nth term is essentially a machine that turns the position of that unit into that unit itself. All right? So if I pass 1 into our machine, we're going to get out 1. But if I was to pass in 2, I want to get out 5. If I was to pass in 3, we're going to get out 9. Okay, and we're just building this machine. Now, to ensure that we jump up by 4 each time, we want 4n, right? Every time I pass in a number, the output is going to increment by 4. But at the moment, if I was to do that, I'm not quite getting the values I want, am I? 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. It's close, but it's not quite 159. How do I get it to become 159? Well, I just need to take away 3 from each of these values. There you go. So the trick is the difference is always the thing before the n. There you go. So 1 times 4 is 4, take away 3 is 1. 2 times 4 is 8, take away 3 is 5. Cool. A couple of fraction questions up next. So we're starting off with some mixed numbers here. I'd always advise that it's a little bit nicer if we turn these mixed numbers into top heavies to get us started. So 3 times 5 is 15, plus the 4, gives us 19 over 5. Same idea over here. 1 times 3 is 3, 3 plus 2 is 5. That's all over 3. Okay, so we're into top heavies rather than mixed numbers straight away. Next, well, we can't currently take these away, right? Because these pizza slices are different sizes. This over here is a pizza that's being split into 3, and this over here is a pizza that's being split into 5 pieces. To be able to actively compare them, we need them to be split into the same amount. Now we can do this by scaling up our fractions. And specifically, we need to find a value that both 5 and 3 go into. And that magical number is 15. You could do 30, you could do 45. There's lots of options, but in our case, let's do 15. It's the first one. So how do we scale 19 over 5 into something over 15? Well, let's just take a little detour over here. I'm just going to do some workings down here. Well, we can say 19 over 5 multiplied, right, by 3 on the denominator will give us the over 15. But we also have to multiply on the top by 3. Well, why is this? Well, this equals 1, right? And multiplying anything by 1 doesn't change it at all. Now, it's a little bit harder doing 19 times 3, but it's 57. Maybe do 20 times 3, take 3. Right. If we run through the same idea with the 5 over 3, well, to get from 3 to 15, we multiply by 5, and of course 5 times 5 is 25. So, lo and behold, to get our answer, all we need to do is find the difference between 57 and 25, which is going to be 32 over 15. This specific question doesn't ask for us to give it as a mixed number, but if we did want to do it, we question how many times does 15 go into 32, and then we leave our remainder as the remainder over 15. In this case, 2 and 2/15. Cool. And then next over here, Kevin was asked to work out 2 1/3 multiplied by 5/8, and we need to identify where his error was. Alrighty, so 2 1/3 times by 5/8. Yeah, okay, that's what we started off with. 7 over 3, yeah, that's looking right. 2 times 3 plus 1 is 7. 5/8 stays the same. Next up, we're multiplying them. 7 times 5 indeed is 35. 3 times 8 indeed is 24. And then here, it looks like they've done their calculation quite slightly wrong. How many times does 24 go into 35, and what's the remainder? Well, it goes in once, but the remainder is not 9. It is in fact 11. So I'd say they converted from top heavy to mixed incorrectly. And if you want to be more precise, you'd say it should be 11, not 9. Okay, on to question 22. We have a floor plan. Okay, it's not a very nice floor plan. It looks like some compound shapes here where we've got different rectangles or squares put together to make this diagram. But let's read the context first to see what's going on. So Petra is going to cover the floor with paint. She has 3 tins of paint, and there are 2.5 litres in each tin. All right, we're probably going to need this. Let's do some maths. 3 tins of paint, 2.5 litres in each tin. She's got 7.5 litres. Cool. 2.5 times 3. Nice. Petra thinks that 1 litre of paint would cover 10 metres squared of floor. Okay, I can see where this is going, right? each litre, 10 metres of floor. All right, we can cover 75 metres squared of floor. All right, we haven't even got to the question yet, but we know that that's how much floor we can cover. Assuming Petra is correct, does she have enough paint to cover the floor? Amazing, right? So we know how much we can cover. It's now just our objective to figure out how big this space is. So having a look at it, there's a couple of different ways we could split it into shapes. I'm looking at this. This is nice. Seems nice, isn't it? So by doing that, we've now got two rectangles. And instead of this weird like L shape, we don't have a formula for finding the area of that L shape, but we do for rectangles. Now this shape on the left has a height of 8 and a base of 6. The area for a rectangle is height times base, so 8 times 6 gives 48 meters squared. We're dealing with meters in this case. But over here, well, we know it's 5 vertically, but how far across is it on the bottom? And this is when we're going to use this 10 meter at the top to help us out. So we know that 10 meters is all the way across. We know that 6 meters gets us up to here. How big's the difference? Well, it is indeed 4 meters. This leaves us with the area of this square up here being 20 meters squared. So the total area is going to be 48 plus 20, which is 68. And this happens to be less than 75 meters squared. So do we have enough paint to cover the floor? Yes. We have enough paint. Oh, there we go. Amazing. Oh, okay. Actually, 1 litre of paint covers 11 meters squared of the floor. Okay. So each litre here could actually cover slightly more. This was actually 11 meters squared. So how much could we actually fill? Well, if each litre can now cover more floor, well, we don't need to figure out exactly what it's going to be, but we know it's going to be more than 75. Right? But 75 meters squared was already enough. So if we've got more than 75 meters squared, does it affect our answer? No. Right? It doesn't affect our answer. No. We already had enough. Assuming if each 1 litre covered 10 meters squared, 11 meters squared gives us even more surplus. Amazing. Okay. Venn diagram question. What's going on here? Question 23. We've already had our Venn diagram populated out. We've got some things in P, we've got some things in Q, we've got some things outside of P and Q, and we've even got that 18 in between both of them. Part A goes right down the numbers that are in the set of P dash. In words, this means not P. Okay, so my advice for these questions is to go, well, what is in P? Well, there's P, that whole circle, even the middle bit, that's also P. So everything that's not in P is everything that remains. So that's going to be 10, 11, 13, 14, 16, and 17. Next up, we have a question where a number is chosen at random from the universal set. You don't really need to know what that is, but that's just the set of everything. It's everything that's going on. Find the probability that this number is in the sets P or Q. Right, I've given this away already. Quite a lot of people ask me, how do you remember which one this is and which one this is? Well, in my opinion, this one looks like an and. There it is. So using logical deduction, you can figure out that this one's an or. So what's the difference between these two things, and or? Well, and is when it's in both P and Q. And the only value that encompasses both is in 18. So what are we looking for when we want or? Well, or means that it's in P or it's in Q. And it could be in both. It doesn't matter. It could be both. So we want all of those values. Now the question for us says, find the probability. We've got one of these numbers being chosen at random, and we want to know the probability of it being in the sort of orange outline, right? This 12, 15, 18, 14, or 10. Now, the way that we find probabilities is the things that we want out of the total amount of options. So in our case, there were 5 things that we wanted. 1, 2, 3, 4, 5 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. That would be our probability. Okay. Next up, we have Sophie driving a distance of 513 kilometers on a motorway in France. She pays 0.81 euros for every 10 kilometers she drives. Work out an estimate for the total amount she would pay. Cool. So the trick for these is we can typically round to the first significant figure. So I would say that we can take this 513 kilometers, and we're just going to estimate it as 500 kilometers. That seems a little bit nicer. You could argue that it could be 510, but let's make it 500 kilometers. And then down here, let's make it to one significant figure. This is going to round to 0.8 euros. So let's do it like this. Becomes 0.8 euros. And so our estimate is going to be these two things multiplied together. And let's have a think about it, right? And this one here is per 10 kilometers. So we can just think about this logically. If we were to do times 10, we'd have 100 kilometers, and this would be 8 euros. And if we wanted to go to 500, we'd multiply this by 5, therefore multiplying 8 euros by 5, which would give us our 40 euro estimate. There it is, 40 euros. Cool. Is your answer to part A an under or over estimate? Well, given that we've actually decreased both of our values, we decreased the distance in our estimate and we decreased the values, we're definitely going to have an underestimate. Why is that? Well, we decreased both values. Well, why is that? Well, it's because in reality, we've got to go slightly further, right? We know that we actually probably should have added another 0.8 euros to get that extra to 510 or at least 513, right? And we actually decreased the value that each 10 kilometers was. It was actually a little bit more. Fantastic. Okay, question 25. Find the equation of L. Okay, straight line equations. Straight line equations, you immediately want to be thinking y equals mx plus c. That thing where your gradient is defined by m and your y-intercept is defined by c. The y-intercept is where your line crosses the y-axis. Haha, that's right here. We've done it already. So the y-intercept we can immediately see is 3. And the gradient, well, there's a couple of different ways of thinking about it. The most common one is to say, well, what's your change in y-coordinate for your change in x-coordinate? I also like to think about it as for every one step I take to the right, how much do I go up or down? In this case, let's do the change in y-coordinate over a change in x-coordinate. And to do this, find a pair of coordinates that align very nicely on the graph with your line. Here are two. Draw yourself a triangle and think about how much have you actually changed on your x-axis. And you want to be thinking as you move to the right. Okay, so we've moved 2 to the right. And then, how much have we changed in our y direction? Well, we've moved 3 upwards. Okay. Now to get our gradient, it's our change in y over change in x. Okay, in our case, 3 over 2. Okay. So if we put this all together, we get y equals 3 over 2x plus 3. M is a different straight line with equation y equals 5x. Write down the equation of a straight line parallel to M. So the idea of something being parallel is that it moves in exactly the same direction. Okay? Two lines are parallel if they never meet or cross. And the thing that defines what direction it goes in, well, that's gradient, right? Remember the y-intercept, well, that can move up or down, but if it's still going in the same direction, they're never going to cross. So actually, to find a line parallel to M, we've got to just ensure that it has the same gradient, 5, but we can give it any y-intercept. And I've just picked 4 here, but you could pick anything here. Other than, of course, this is a plus 0, right? So anything here is fine. Let's just say y equals 5x plus 4. But you could just go and put 1,000,000 if you wanted to. There's nothing stopping you from doing that. On to question number 26. Kazim has some small jars, some medium jars, and some large jars. He has a total of 400. 3/8 of the 400 are empty. Okay, and then we've got some stuff happening afterwards. Let's work out how many are empty. Yeah, okay. Work out the percentage of jars that are empty and small. Okay, cool. So, if 3/8 of 400 are empty, the way that I'd suggest we do this is work out how many times 8 goes into 400, and then we can multiply that value by 3 of 400. This would be great if it was on a calculator paper, but not quite as nice here. This is quite a hard calculation. Maybe you'd spot it quite quickly, maybe not. But I mean, let's just run it through a bus stop as well. Why not? 8s into 4, none. So 8s into 40 goes 5 times. 8s into 0 goes no times. 50. Oh, yeah, cool. There you go. Okay. So if we wanted 1/8, it would be 50. We want 3/8. So we know that 150 jars are empty. Now, for the empty jars, the number of small jars to the number of medium jars is 3 to 4. And the number of medium jars to large jars is 1 for every 2. So we actually want to figure out, well, how many are going to be small jars? That's our objective. And actually we want a percentage as well. So let's start by looking at these ratios and seeing what we can do. So we have small to medium to large. And I like to lay out our data like this. I don't like it very much like this. It doesn't look very nice. So we know that small to medium is 3 to 4, and medium to large is 1 to 2. Now, we want to combine this into one set of sort of nice ratio, right? But we can't currently. 4 is different to 1. So we need to scale up 4 and 1 so that they're the same value. And in our case, this is actually way nicer. We can just get it to 4, right? Our ratio here, we can scale up by a factor of 4. 1 multiplied by 4 gives 4. 2 multiplied by 4 would give 8. In our top ratio over here, we already have 4. So we can just drop this 3 down. Boom. All right. So this gives us an idea of what ratio of the jars we've got. The ratio itself has a total, right? We can add these together. 8 plus 4 is 12, plus 3 is a total of 15. Okay, now this is awesome, right? So what does this tell us? For every 15 jars, 8 are large, 4 are medium-sized, and 3 are small. We've got 150. It's 10 times as much, right? So we can scale up our ratio and our total here by 10. And all of a sudden, we're left with the amount of each size of jar. We want the small ones. So there we go. We're left with 30 small jars are empty. So work out the percentage of Kazim's jars that are empty small jars. So 30 of them are empty. He had 400 in total. Okay, so we've got it as a fraction. Now our next move is to turn this into a percentage, just to finish off our question. And this doesn't look particularly nice, so we might have to be pretty strategic with how we do this. I would suggest that our first move is actually to simplify it as a fraction. Notice we can decrease both top and bottom by 10, giving us 3 over 40. But this isn't quite the nicest place to be yet, is it? We can't actually do very much here. And actually, in retrospect, I think there might be a slightly nicer way. Remember that to get something into a percentage, well, we just want to get the denominator to equal 100. So if we divide this by 4, we get 100. What happens when we do 30? divided by 4. Well, that's a little bit hard, but remember dividing by 4 is divide by 2 and then divide by 2 again. 30 divided by 2 is 15. 15 divided by 2, 7.5. So not the nicest question there, but we are left with 7.5%. Yeah, for 5 marks, I think this is quite a reasonable amount of marks for that question. A lot of stuff going on. Not only a hard fraction to begin with, we then had a 3-part ratio and a conversion all in one question there. So very good question. All right, on to question set 27 now. So in a sale, normal prices are reduced by 30%. The sale prices of a TV is 280. Work out the normal price. Okay, so we have a normal price. Normal. To get the discounted price, we reduce it by 30%. This is the same as multiplying it by 0.7. Okay. If we multiplied it by 1, we'd have the whole value. But if we were to decrease it by 30%, well, we end up with 70% of the value, or 0.7. And this is going to equal the sale price. Now, we know that the sale price is 280. Okay, it's pretty good. We don't know what our normal value is, and we do know what the discount is, 0.7. So a little bit of rearranging here, and we're left with x is equal to 280 divided by 0.7. Now that doesn't seem like the nicest thing in the world, but we can make it a little bit easier for ourselves. We know that, well, 280 is the same as 70%. Right? So what we can do is we can actually divide by 7 to get 10%. What's 280 divided by 7? Well, it is 40. Maybe not the most obvious thing in the world. How many times does 7 go into 28? 4 times. We're doing it 10 times as many times. Therefore, now it's quite nice. If we wanted 100%, well, we just multiply everything by 10. So £400. Nice. And then on to our final question. Question 28, a very, very tough looking inequality over here. So how are we going to approach this? Well, there's a couple of different ways. A lot of teachers will lead you towards maybe putting in an equality sign rather than an inequality. And this holds true most of the time. So we can do that. There are a few times where it doesn't. I'm personally going to leave the inequality in for the whole calculation, but it doesn't matter if it's an equality here. But our first objective is to get all of the x's to one side and all of the numbers to the other. Now, I would always advise that you want to make sure that your x's stay positive. It just yields a slightly nicer flow of maths as you go through it. So, for example, instead of taking away the x from the left-hand side and moving it to the right, let's definitely add this half x to the left-hand side. So we've got 1x, and we're going to try and add this half x over here. And we're going to be left with 3 over 2x plus 11 is less than or equal to 5. Our next objective is to make sure that we've just got x's on one side and numbers on the other. So to do this, we're going to take away that 11, leaving us with 5 take away 11 minus 6. And now we're left with quite a weird thing. 3 halves, or 1.5 times x, is less than or equal to minus 6. But we want just x, right? So we're going to have to divide by 3 halves. Now that feels like a bit of a weird calculation, right? But maybe there's a nicer way of looking at it. We can consider minus 6 as 3 parts, and we want 1 whole, right? 2 over 2. So we currently have 3 parts, and we want 2 parts out of it. So if we were to divide minus 6 by 3 and then multiply by 2, we're left with minus 4. You could argue that you'd want to see this more concisely, so I'll do it in a more detailed way. If we were to do minus 6 over 1, and you know that you wanted to divide it by 3 over 2, this is the same as minus 6 over 1 multiplied by 2 over 3, which is the same as minus 12 over 3, which is equal to minus 4. Okay, you can work it through in different directions and still yield the same value. But yeah, that leaves us there with x is less than or equal to -4. Cool, and that wraps up our paper. So that there was the 2024 paper 1 for Foundation in Edexcel. So very nicely done there if you've managed to work your way through it. I hope you did well in it and you were happy. If you weren't, definitely go and take a look at how I solved some of these questions. And yeah, if you've got any comments or thoughts on any of these questions, maybe you solved it in a different way, feel free to let me know below. I look forward to hearing about what you guys have said. But anyways, I will see you in the next one. Bye now.